Unit 5. Teaching Chemical Concept. Unit Introduction. One should be aware that newly acquired concepts are not sustainable forever, and can be easily affected when lessons are over. Concepts regarding life in general, which have been sustained over several years, are more deeply rooted than new concepts, which have more recently been picked up in lessons. It is therefore necessary to repeat and intensify these newly acquired concepts in order to anchor them in the minds of students. The concept of scientific literacy emphasizes that science plays a key role in everyday life. Scientific knowledge leads to a deeper and more sophisticated understanding and describing of everyday life situations, and can be seen as an important part of general education. The unit explains the basic chemical concepts, concept analysis in chemistry, and class of concepts. Chemical concept mapping is one of the simple way in teaching chemistry and simplify difficulties in chemistry. The other part that simplify difficulties in chemistry is drawing concept map. Learning outcomes. Upon completion of the unit, you will be able to define concepts, distinguish chemistry concepts, analyze different chemistry concepts independently and in group, classify science concept by using chemistry examples, explain the difficulties in teaching chemistry concept, formulate chemistry concept analysis strategies, draw different chemistry concept maps, select different chemistry concept to draw a concept map, explore the understanding of chemistry concepts in gas laws, conservation of mass, oxidation and reduction, hydrocarbons and its derivatives, chemical equilibrium, solutions, etc. Section 5.1. Chemical Concepts. Activity 5.1. Mention important chemical concepts based on your previous knowledge of chemistry. What makes chemistry concepts difficult? Chemistry is one of the most important branches of science. It enables learners to understand what happened around them. Because chemistry topics are generally related to or based on the structure of matter, chemistry proves a difficult subject for many students. Chemistry curricula commonly incorporate many abstract concepts, which are central to further learning in both chemistry and other sciences. These abstract concepts are important because further chemistry/science concepts or theories cannot be easily understood if these underpinning concepts are not sufficiently grasped by the student. Teaching general chemistry course at high school level can be very challenging. The main challenge is to help students think chemistry. Chemistry deals with all the materials of the universe, including all living things. Everything is composed of atoms chemically combined to form molecules. Most high school chemistry textbooks are content-oriented, where students are presented with chemical facts, formulas, and principles. Only a few textbooks make a conscious effort to help students develop critical thinking and problem-solving skills that will aid them later in life. Students must be encouraged to develop a full understanding of chemical concepts. They must also be guided to develop their own mental models of basic concepts. Students often leave a chemistry course being confused, and are reluctant to enroll in another chemistry course, or worse yet, another science course. This limits their career choices and their ability to discuss societal issues involving science. We are not only providers of that knowledge, but we must enable students to observe how that knowledge is relevant to their lives, if they are going to retain it over a period of time. Perhaps by adding some sugar to the water we will be able to become more successful with this process. Teaching in context is not about teaching the chemistry content and then providing real-world applications of this content. It is about using real situations that can be explained through the use of chemical concepts. Activities 5.2. Take 2 test tubes. In the first test tube add sodium chloride. In the second test tube add sodium hydroxide. If you add water in both test tubes, you will observe that the second test tube releases heat, and the pH of the solution is very high. Make a group of 5 students and discuss the 2 reactions as physical process or chemical processes. Instead of boring students with lecturing to teach new chemical concepts, I wish you successfully introduce topics with teacher demonstrations and discussions. I also want students to have the opportunity to perform more hands-on activities. You can practice the following activities by doing experiments in the lab or at home. Electrolytes and Electrochemistry. Compounds that conduct an electric current in aqueous solution, or in the molten state, are known as electrolytes. This is due to the fact that ions are free to move about in the solutions. The degree of conductivity depends on the solubility of the ionic compound and the number of ions present in the solution. Covalent compounds do not contain ions and are thus referred to as non-electrolytes. Teacher demonstration and discussion. To introduce this topic, a simple teacher demonstration involves salt and sugar. Using a conductivity tester, test the following salt crystals: a dilute solution of salt water, a more concentrated salt water solution, sugar crystals, a dilute solution of sugar water, and a more concentrated solution of sugar water. Before each test, have students predict whether the substance will be a good electrolyte, a poor electrolyte, or a non-electrolyte, and give a reason why. The more concentrated the salt water solution, the better the conductivity. All sugar solutions will be non-electrolytes. Materials needed: a conductivity tester homemade, 6 small beakers, sodium chloride, sucrose, and water. Student activity. Electrochemistry uses a chemical reaction to generate electricity. An ordinary battery is an example of electrochemistry as everyday life. One interesting activity for students involves making a battery from a lemon. The lemon should first be rolled gently on a hard surface, such as a tabletop, to make it really juicy inside. Caution students not to roll too hard and rupture the lemon peel. 2 different metal strips are needed to act as the electrodes. Copper wire and a strip of zinc are good to use, or a steel paper clip in place of the zinc strip. Push the pieces of metal into the lemon so they are as close together as you can get them without touching one another. Electrons will migrate to one electrode, creating a negatively charged terminal, and at the other electrode there will be a loss of electrons, creating a positive terminal. Connect 2 lemons together in series using a very thin wire. A single lemon produces about 0.7 volts of electricity. Thus 2 lemons should produce enough electricity to power an inexpensive digital watch which uses about 1.5 volts. Finally, have students connect more lemons together and try to light a small light bulb from a flashlight. Materials needed: a lemon, 2 different metal strips, copper wire, zinc strip or steel paper clip, pieces of fine wire, and an expensive digital watch, and a small light bulb from a flashlight. B. Chemical reactions. A chemical reaction is a process in which the original substance's reactants undergo change to form new substances products. The new substances formed have a different set of physical and chemical properties. During a chemical reaction, bonds between atoms are broken, atoms are rearranged, and new bonds are formed. The driving force for chemical reactions is stability. Thus, most chemical reactions are exothermic, which means that heat is released. The products have less energy, and the reactants. Chemical reactions are classified into 5 general types: combination synthesis, decomposition, single displacement, double displacement, and combustion. Teacher demonstration and discussion. A double displacement reaction can be demonstrated by simply mixing vinegar acetic acid and baking soda sodium bicarbonate together. Have students predict the products and write a balanced chemical equation for the reaction. Materials needed: vinegar acetic acid and baking soda sodium bicarbonate. Student activity. A somewhat smelly reaction for students to perform is the decomposition of table sugar sucrose. Have students place a spoonful of sugar into a test tube. Using a test tube holder, heat the sugar for several minutes by holding it over the flame of a Bunsen burner. Have students observe and record any changes that occur as the sugar is heated. Be sure to do this in a well-ventilated room. At the completion of the activity, students should be able to predict the products of the reaction and write a balanced chemical equation. The products are water vapor and carbon. Another alternative is to use baking soda instead of the sugar. It is not as dramatic and produces very little smell. Place some baking soda in an evaporating dish. Add 3.0 mHCl to the dish and observe. Have students conduct a carbon dioxide test by holding a burning wood splint above the dish. If the flame goes out, carbon dioxide is present as one of the products. The other products are sodium chloride and water. Remind students this is a double displacement reaction. Materials needed: sucrose, a test tube holder, baking soda sodium bicarbonate, evaporating dish, a Bunsen burner, and a wood splint. See acids and bases. Acids and bases have very different chemical properties. Acids taste sour, react with metals, and are proton donors, while bases taste bitter, feel slippery, and are proton acceptors. A solution with a pH less than 7 is said to be acidic. On the other hand, a solution with a pH greater than 7 is classified as basic. A neutral solution has a pH of 7. When an acid reacts with a base, a neutralization reaction occurs, producing water and a salt. Teacher demonstration and discussion. To introduce this topic to students, ask students to hypothesize about the chemical reactions involved with baking powder. Begin by having students identify common foods made with baking powder. Next, list the main ingredients of baking powder and the chemical formula for each on the board. Students should be able to recognize that sodium bicarbonate is a base and the other substance as an acid. The acid varies with brand name and type. Some common acids used are potassium tartrate, monocalcium hydrogen phosphate, and sodium aluminum sulfate. Ask students to predict why the acid and base are not reacting when mixed in the powder. The neutralization reaction will not occur until the dry ingredients are mixed with the wet ingredients. This may be in the form of water, milk, or some similar liquid. The acid used determines the speed of the neutralization reaction. This is important because it affects how quickly the batter must be mixed and cooked. Double-acting baking powders have two different acids. The first one reacts with the sodium bicarbonate at room temperature, while the second one reacts later after the batter has been baking a while and the temperature has risen. This ensures a prolonged production of carbon dioxide and a lighter and tastier baked product. Materials needed: baking powder and double-acting baking powder. Student activity. Students can prepare their own acid/base indicator solution and test various food items to determine which are acidic, basic, or neutral based on color change. One simple indicator solution involves red cabbage. Cut a few red cabbage leaves into smaller pieces and place in a beaker. Add enough water to cover the cabbage leaves. Boil the mixture until the color of the water is purple. After straining the liquid, discard the discolored leaves. The purple liquid is the red cabbage indicator. The indicator turns from purple to red in the presence of an acid, and from purple to blue in the presence of a base. Students can test a variety of foods such as soft drinks, various kinds of fruit juices, tap water, salad dressings, vegetables, and etc. Materials needed: red cabbage, a large beaker, one hot plate, a large filter or strainer, a variety of food items. States of matter. Solids, liquids, gases, and plasma make up the four main states of matter. One particularly intriguing state of matter to study is gas. Gases have no definite volume or shape, and are highly compressible. Gas particles are in constant random motion, undergoing many collisions with each other and the walls of their container. This results in gas pressure. Air is a mixture of many gases. Air exerts a pressure on the surface of the Earth that is easily measured with a barometer. Teacher demonstration and discussion ask students to hypothesize about the relationship between atmospheric pressure and altitude. At high altitudes, atmospheric pressure decreases due to fewer molecules. Since the boiling point of a liquid is defined as the temperature at which the vapor pressure is equal to the atmospheric pressure, the boiling point decreases as altitude increases. Food manufacturers are well aware of this relationship and provide cooking instructions for normal and high-altitude conditions. Ask students to bring in food products that have special directions for cooking or baking at higher elevations. Many cake mixes and frozen food packages have such directions. Materials needed: directions from food products, cake mixes, frozen foods, etc. Student activity. Boyle's law states that volume and pressure of a gas are inversely related at constant temperature. Have students investigate Boyle's law by using popcorn. Add some unpopped kernels of popcorn to a large beaker. Cover the beaker tightly with clear plastic wrap. Make a pinhole in the center of the plastic. Place the beaker on a hot plate and observe what happens. Repeat the same steps using kernels of popcorn that have pinholes in the shell, like covering hole. Compare your results. Caution students to allow the beaker to cool before removing the plastic wrap. Students should be able to recognize that inside each kernel there is a small amount of water. When the kernel is heated, the water becomes superheated steam. These rapidly moving water molecules cause a tremendous increase in pressure on the hull. Eventually the hull ruptures, and the kernel explodes. Emphasize to students that when the hull ruptures, the pressure surrounding the starchy substance inside the kernel is greatly reduced. The water now vaporizes and expands as described by Boyle's law. If holes are punched into the kernel prior to heating, the kernel will not pop. This is due to the fact that steam is able to escape through the holes, and there is no buildup of pressure inside the kernel. Materials needed: popcorn kernels, a large beaker, plastic wrap, 1 hot plate, and a small pin. Chemistry is one of the most important branches of science. It enables learners to understand what happened around them. Because chemistry topics are generally related to or based on the structure of matter, chemistry proves a difficult subject for many students. Chemistry curricula commonly incorporate many abstract concepts, which are central to further learning in both chemistry and other sciences. These abstract concepts are important because further chemistry/science concepts or theories cannot be easily understood if these underpinning concepts are not sufficiently grasped by the student. Section 5.2 Concept Analysis in Chemistry. Concept formation is the process of integrating features to form ideas by the recognition that some objects or events belong together, while others do not. The concept formation is based on stimulation, direction, and guidance. In it, more emphasis is on thinking, and less upon memorizing, more on understanding, and less on merely accumulating facts, and more on learning through genuine interest, and less on learning through coercion. The abstract nature of chemistry along with other content learning difficulties, e.g. the mathematical nature of much chemistry, means that chemistry classes require a high-level skill set. Chemistry is often regarded as a difficult subject, an observation that sometimes repels learners from continuing with studies in chemistry. Most teachers find the basic concepts of chemistry, matter, substance, element, compound, solution, etc., difficult to teach. This is partly because the definitions of these concepts given in textbooks either lack precision or invoke ideas that beginners are not familiar with and have to accept on trust. One of the essential characteristics of chemistry is the constant interplay between the macroscopic tangible things from the macroscopic world around us that can be seen and characterized with our eyes, ears, etc., and microscopic things from the macroscopic world that are too small to be seen, but which can still be characterized using microscopes and other measuring tools. Levels of thought. And it is this aspect of chemistry learning that represents a significant challenge to beginner. Chemistry is also represented by symbols, formulae, equations, and mathematical manipulation. While much can be acquired by rote learning, real understanding demands the bringing together of conceptual understandings in a meaningful way. But to fully understand chemistry, it has to move to the submicro situation, where the behavior of substances is interpreted in terms of the unseen and molecular and recorded in some representational language and notation. This is the strength of our subject, but also the weakness of the subject when we try to teach it, or more importantly, when beginner students try to learn it. Activity 5.3. A teacher tries to show that gases expand on heating, and tries to introduce a kinetic picture, and even some simple mathematics. The student remembers that things in general expand on heating, ignores the kinetics, and rationalizes the experiment by assuming that the atoms have expanded. Identify the three forms of chemistry: macro, submicro, and representational, and discuss with a group of 5 and provide written report. The abstract nature of chemistry along with other content learning difficulties, e.g. the mathematical nature of much chemistry, means that chemistry classes require a high-level skill set. Chemistry is often regarded as a difficult subject, an observation that sometimes repels learners from continuing with studies in chemistry. Most teachers find the basic concepts of chemistry, matter, substance, element, compound, solution, etc., difficult to teach. This is partly because the definitions of these concepts given in textbooks either lack precision or invoke ideas that beginners are not familiar with and have to accept on trust. One of the essential characteristics of chemistry is the constant interplay between the macroscopic tangible things from the macroscopic world around us that can be seen and characterized with our eyes, ears, etc., and microscopic things from the macroscopic world that are too small to be seen, but which can still be characterized using microscopes and other measuring tools. Levels of thought, and it is this aspect of chemistry learning that represents a significant challenge to beginner. Chemistry, by its very nature, is highly conceptual. While much can be acquired by rote learning, real understanding demands the bringing together of conceptual understandings in a meaningful way. Activity 5.4. The above activities could be home-take task. As you go through the activities, you will understand the importance of chemistry, and the concepts of chemistry will not be forgotten. You can make a group of 5 students in your class and give one activity for each group, and students will produce a report. You need to compile a report prepared by the group and present it in class. Concept formation is the process of integrating features to form ideas by the recognition that some objects or events belong together, while others do not. The concept formation is based on stimulation, direction, and guidance. In it, more emphasis is on thinking, and less upon memorizing, more on understanding, and less on merely accumulating facts, and more on learning through genuine interest, and less on learning through coercion. Teaching chemistry concepts in our educational system mostly follow the traditional way. For example, an acid-base mole calculation involves a number of steps which are likely very difficult to understand. The steps are: write formulae for the acid, the base, and the products. Insert these into an equation and balance it. Establish the stoichiometric relationship between the acid and the base. Calculate the number of moles of the acid in the given solution, and hence the number of moles of base needed for neutralization. Convert the number of moles of base into a volume, if molarity is given, or into a molality, if volume is given. The above concept could be introduced by another approach. Now let us split the problem into 3 simple steps. The problem is: what is the molarity of a solution of sodium hydroxide, when 80 milliliters of it can exactly neutralize 40 milliliters of 0.1 molar sulfuric acid? Making it concrete and dividing the problem. Visualize the beaker containing the acid. How many moles of H plus are in it? Molarity x volume in liters x number of H plus per formula of H2, so 4 equals 0.1 by 50/1000 times 2 equals 0.01 moles H plus. Now visualize the beaker containing the base. How many moles of O are in it? Molarity x volume in liters x number of O per formula of NaO. Zx 80/1000 times 1 equals 0.08 moles O. At neutralization, no. H plus equals no. O. 0.01 equals 0.08 ZZ equals 0.125 molar. You can see that the above solution has no balancing and no equation. The usual method of calculation was followed, but not the blind formula N1V1 equals N2V2. Section 5.3. Class of concepts. The basic concepts in chemistry are difficult to understand for students. The level of difficulty in chemistry is discussed in one of the chapters in this module. Concepts can be grouped in some forms, and some of them are 1. Organization. Scientists have made the study of science manageable by organizing and classifying natural phenomena. For example, compounds can be organized as acids, bases, and salts. Chemistry students can be introduced to this concept at early stage, and classify compounds further into strong or weak substances. 2. Cause and effect. Searching for explanations is the major activity of science. Effects cannot occur without causes. Students can learn about cause and effect by observing the effect that acids have on different metals. Students can discover reactive and unreactive metals in acid. Activity 5.5. Consider 2 metals. Na-metal is reactive in water and acids. Zn-metal is unreactive in water, but reactive in acids. Discuss the activity of the 2 metals. Based on the position of the 2 metals, one metal from S block and another metal from D block, select 2 metals from the periodic table and tell to the group the reactivity of the metal in water and acid based on the above classification. 3. Scale refers to quantity, both relative and absolute. Thermometers, rulers, and weighing devices help students see that objects and energy vary in quantity. 4. Models. We can create or design objects that represent other things. Molecular models, which are assisted by computers, help students to understand better than actual experiments. During electrolysis process, you cannot see the flow of electrons from the anode to the cathode, but computer models help students to visualize electron flow. 5. Change. The natural world continually changes, although some changes may be too slow to observe. Rates of change vary. Students can be asked to observe changes in the corrosion of different metals in different environmental conditions. Students can also observe and describe changes in the properties of water when it boils, melts, evaporates, freezes, or condenses. In text question 5.1. In many chemical reactions, mass does not appear to be a conserved quantity. For example, when a tin rusts, the resultant rusty tin has a greater mass than before rusting. When a candle burns, the remaining candle has invariably less mass than before it was burned. Provide an explanation of these observations, and describe an experiment which would demonstrate that mass is actually conserved in these chemical reactions. Section 5.4. Chemical concept mapping. Concept mapping graphically illustrates the relationships between defined concepts and / or the characters. There are 2 types of concept mapping: hierarchy mapping and spider mapping. Hierarchy map shows the hierarchical relationship of an overarching defined concept and subordinate or lower-level concepts. For example, one can consider the classification of matter as hierarchical mapping. Spider map shows the relationship of a single defined concept and its defined characteristics and related concepts. Chemistry is a pure and mature discipline. It has a systematic knowledge base. The use of concept mapping can help students begin to understand interrelationships among concepts. This method can arrange concepts through interacting systems. In this system, all relationships between concepts are made clear. This method is suitable for developing students' cognitive structures. It can also contribute significantly towards meaningful learning in the mind of the student. The teaching progresses from the societal and the familiar to the chemistry concepts, the unknown, which are needed to better appreciate the issues or concerns, and then proceeds to the socio-scientific decision-making needed, the purposeful learning involving all educational domains. The following figure shows concept mapping to study chlorine. Activity 5.6. Improve the concept map of chlorine by considering problem-solving components such as purifying drinking water, oxidation process, whitener, household cleaner. Make a group of 5 and improve the concept map of chlorine based on the above given facts. Section 5.5. Difficulties in teaching chemistry concepts. In text question 5.2, what are the main areas of learning difficulty? What are the main aspects of reducing obstacles to learning? The nature of chemistry concepts and the way the concepts are represented, macroscopic, microscopic, or representational, make chemistry difficult to learn. Many empirical studies have reported that students encounter great difficulties in comprehending the theoretical scientific concepts in biology, chemistry, and physics. Indeed, the complexities of science concepts also pose serious challenges to teachers in their attempts to impart that knowledge to the students. Like students, teachers had been reported to have serious misunderstanding of some of the science concepts. This has a serious repercussion when the wrong concepts are conveyed to the students, as a result of teachers' lack of deep understanding of the subject matter knowledge, inaccurate teaching, or uncritical use of the science textbooks. There are 5 areas of concern in learning difficulties in chemistry. 1. Curriculum content. All textbooks start with topics like atomic theory, bonding, formulae, equations, balancing ionic equations, calculations, and stoichiometry. Some of the topics are repeated once more in other grade levels. For example, atomic theory is given in both grade 9 and 11. Electrolysis is given in grade 10 and 12. Different topics are treated at different classes in different depth, and misconception at lower level hinder the understanding of the topic at higher level. Therefore, it is better to treat atomic structure at grade 9 and electrochemistry at grade 10. In text question 5.3, list all topics from grade 9 to 12. How many topics are treated twice at different grade levels 9 to 12? Discuss and design possible arrangement of topics. And 2. Language and communication. The confusion with words used in Amharic language and science language create confusion for teachers and students. The word amorphous means big size of fat man or woman. When you teach the word amorphous, the misconception of the word must be carefully discussed before going into the chemistry concept of amorphous, a substance with no crystal structure. Language problems include unfamiliar or misleading vocabulary, familiar vocabulary which changes its meaning as it moves into chemistry. For example, the word volatile was assumed by students to mean unstable, explosive, or flammable. Its scientific meaning of easily vaporized was unknown. The reason for the confusion was that volatile, applied to a person, does imply instability or excitability, and this meaning was naturally carried over into the science context, with the difficulties students have with chemistry may not necessarily be related to the subject matter itself, but to the way of talking about it. Language influences the thinking processes necessary to tackle any task. The weak vocabulary of the students as second language speakers in Ethiopia is one of the major problems for learning difficulties. 3. Concept formation. Question. Please write down the first 5 concepts appearing in your mind about chemistry in each grade. Activity 5.7. Chemistry is given from grade 7 to 12 in Ethiopian curriculum. Select students from each grade who scored above 85% on final examination in chemistry. The age difference must be 1 year between successive grades. You can introduce a chemistry concept for each student and see the concept development at each grade level and age. You can conduct a mini-project in your school and produce a report. The following are chemistry concepts and examples are given in the next column. For a given set of questions, students may give different explanation based on the grade level and based on the level of understanding of the chemistry concepts. Similar concepts can be raised, and possible explanation could be gathered during class activity. The diverse answers and difference on understanding concepts is different at different grade level as well as exposure to the chemistry concepts. The explanations given by students at different grade level and age level shows that the first respondent is at lower stage of chemistry concept, or younger age, to understand chemistry concepts. Concept formation is the process of integrating features to form ideas by the recognition that some objects or events belong together, while others do not. Once the objects or events have been grouped according to a particular categorization scheme, a label is given to the group. The end result of concept formation activities is the connections among the common characteristics of a concept. The concept formation is based on stimulation, direction, and guidance. In it, more emphasis is on thinking, and less upon memorizing, more on understanding, and less on merely accumulating facts, and more on learning through genuine interest. Principles of concept formation will be properly introduced for students by the following means. 1. Use of advanced organizers. The teachers can use advanced organizers as a tool to convey large amount of meaningful material in an efficient manner. This is a bridge technique that utilizes the student's prior knowledge to introduce a new concept. 2. Use of guided discovery. Elaboration is the addition of meaning to new information through its connection with already existing knowledge. It is a process whereby the learner expands upon the information given to them during a lecture, reading assignment, etc. 3. Use of guided practice. The guided practice is related to the teaching and overt behavior in which students' first attempts with new learning are guided for accuracy and successful learning. Teachers must closely monitor the student performance during the instruction. 4. Use of inductive reasoning. Generalizations are drawn from particulars, principles are framed from observations, and rules are made from instances or examples. 5. Use of deductive reasoning. In deductive method, rules, principles, and conclusions are applied to particular cases. 6. Use of experiential learning. The experiential learning is based on the notion that understanding is not a fixed or unchangeable element of thought, but is formed and reformed through experiences. Unless these fundamentals are understood, topics including reaction rate, acids and bases, electrochemistry, chemical equilibrium, and solution chemistry become arduous. Real understanding requires not only the grasp of key concepts, but also the establishment of meaningful links to bring the concepts into a coherent whole. Group work, dialogue, and the exchange of ideas may all be very important in allowing misconceptions to be corrected effectively. Section 5.6. Teaching chemistry concepts using concept analysis and concept mapping. In text question 5.4. 1. What is the use of map in geography? For instance, for a tourist coming from USA to visit Ethiopian highlands. 2. What is the impact of concept mapping in chemistry on the content and the structure of the student's knowledge? Concept mapping supports students in making connections between known information and new information. By creating concept maps, students clarify their understanding of the topic and integrate new ideas into their thinking. Concept maps are a visual way to represent relationships among ideas. Concept mapping helps students integrate new ideas with their existing knowledge. You have studied heat energy and 3 ways of heat transfer: radiation, convection, and conduction. Radiation comes from the sun's rays and heats the earth. Convection is made up of convection current, which are formed by hot and cold air. Hot air expands and rises, but cold air sinks and contracts. Conduction occurs between 2 objects. The objects must have different temperature and must duff each other. Such concepts are simple and you can practice concept mapping. Activity 5.8. Draw a concept map for heat energy and discuss the result. Explain the positive and negative results of concept mapping. The secondary school and college knowledge of science is often characterized by lack of coherence. Instead of having well-structured and integrated domain-specific knowledge structures, students consider the different concepts as isolated elements of knowledge. Students do not possess a well-founded basic framework in which newly acquired concepts can be integrated. This lack of integration is suspected to be at the basis of students' difficulties concerning concept formation and application of acquired knowledge in exercises. Consider electrochemistry concept in our curriculum. One can find the topic in grade 10 and grade 12 chemistry textbook. The topic is considered as difficult concept for students and teachers. Electrochemistry is a topic for which teachers seldom use adequate visualization methods. At best, the teacher uses drawings as highly schematized and oversimplified simulations of electrochemical phenomena. Real-life experiments are seldom done in ordinary teaching because of the micro-scale of these phenomena. Basic techniques for building concept map with teachers and students. Role: Teacher prepares by developing list of all important core concepts for unit or lesson. Initiate concept mapping activity by eliciting key concepts for students based on reading assignment, class activities, or students' prior knowledge. Use chalkboard, chart paper, or any other material to create initial concept map. Students: suggestion to the teacher in terms of concept to add or to delete. Arrows that represent the flow of ideas. Concept links. Concept maps can facilitate learning skills in many ways, e.g. note-taking, textbook comprehension, organization for papers, project planning, preparation for examination. The map can promote general conceptual understanding through identifying cause-effect relationships, prioritizing and organizing concepts, and displaying other meaningful patterns of ideas. Considering transferability and students' learning skills, many authors found concept mapping skills to be powerful learning tools for enhancing students' performance. Unit Summary. Students can practice concept mapping based on the daily life of a person. For example, if you are planning to succeed in your grade or college life, the following concepts are very important: health, which is related to nutrition, sleep, exercise, place for help such as library, university, family member, study habit, time management, place of study, money, job, loan, assistance, scholarship, outside life, family, friends, society. Students can try to draw a concept map from daily activity and extend the idea to science topics. Concept mapping can facilitate learning and can be also fixed on walls so that students will see it frequently. Concept mapping also gives the overall picture of the process and helps the learner in many ways. The other portion of this unit is concept analysis. Memorizing the definition of a topic or a term is not the only part of the learning process. Concept analysis using different methods, such as experimental, real object, etc., is very important in understanding chemical process. Assessment mechanism. 1. Draw the concept map of Keiko 3 and produce simple poster for the class. 2. Consider the dissolution of sparingly soluble salts in aqueous solution. Write possible chemical reaction that will take place during the process. Group discussion in pair. 3. Among the means that we'll use to form concepts in chemistry, which one do you think will be appropriate to make relatively stable and permanent learning? Written report.